Hello everyone, my name is Piotrowski and I'm going to give you details about the implementation of events that we introduced in version 3.6 of Ovirt. This work is the next step in evolution of Ovirt communication interface. And this was built upon foundation that was laid in 3.5. So let me give you brief overview and the content of the session. So at the beginning, I want to cover why we decided to go in that direction and give you all the details. What were the main pain points why we have decided to introduce this functionality. In what's new, I will give you the detailed information exactly how you can use the new infrastructure and what are the differences between what we had in 3.5 and in 3.6. As a next part of the presentation, I will cover the flow differences, how Ovirt engine interacts with DSM. Next section of this presentation will be about how to use it. At the beginning, on the engine side, how to subscribe to events. And from the DSM perspective, we'll cover how to actually trigger the events. After that section, we'll talk about where do we stand today and what are the implementations that actually use this infrastructure. And as the last part, we'll cover the future plans, how we want to evolve communication layer in Ovirt in future releases. So starting from the motivation and issues that we had and faced for several releases already. So one of the biggest points that we have is that the communication between engine and VDSM was always one side. So engine always asked VDSM for the information. There was no way for VDSM to send that information. And this is not a great thing because we had to periodically pull for information, and that was implemented as a quartz jobs. So if there were any wrong running tasks, or we wanted to collect metrics and monitoring information from VDSM, it was based on quartz, and it was triggered periodically to gather the data from VDSM. And from that perspective, if we had a bunch of jobs that actually performed those information requests periodically, it meant from the engine perspective, it was the higher utilization because we had to provide resources for the threads that were running the jobs. And from the networking perspective, there is significant increase of traffic over the model when both sides actually can initiate the conversation. If we wanted to have some information from DSM, we had to ask for it. And if the information was not ready, for example, if one of the tasks is running really, really long, then we had to ask several times at least to understand what happened on the other side. So those are the motivations for the change. And this is how actually that was solved. So as a first, we introduced the notion of asynchronicity in the engine. So as you know, in 3.5, we introduced Jsonrpc, which was using exactly the same interfaces and was replacement for XML-RPC. Jsonrpc works in asynchronous way, but we had to cover the asynchronous behavior from the engine perspective and work in the same way as XML-RPC. So right now we are exposing that information, and I will further on I will give you information actually how to use it. So right now you can actually check whether your response arrived or not. If not, then you can do something else in that time. I will cover more how the notification, the event, looks like in terms of format, so we will understand how the message is structured. And one of the most important features for that change is the bidirectional data exchange. So right now with this infrastructure, we can actually trigger information. We can actually send the information from VDSM to the engine, which was not possible before. We were exploring in terms of communication changes whether to have like a broker in the middle, and then we could actually use nice messaging system between VDSM and the engine. And for this release, we have decided to have so-called mini broker, which is internal implementation within VDSM. There were few topologies that we looked at, how we could use it when we wanted to use external brokers, so we could have the broker on the box with VDSM or somewhere externally to VDSM and the engine. But for this release, we have decided to go with our own implementation of the broker, and I will give you more details about it later on. So in terms of consuming the events on the engine side, we had to implement a mechanism for the engine actually to deliver the events to proper pieces of the code, which are responsible for processing the data. And as a solution for that issue, we have decided to actually leverage Reactive Streams API and deliver the events to proper places. So right now, the engine, the different parts of the code in the engine can subscribe to a particular type of the event. I will cover that later on. We don't have full implementation of reactive streams, but we may actually have full implementation once we see that there is a need for it. I will cover that more in future plans for evolution of transport layer in Orbit. And having said that VDSM triggers events and the engine receives them, we had to introduce a concept that will allow us to understand from which part of VDSM the event was triggered, and based on that information, we had to decide where to deliver the event. So as a solution for that, we decided to create subscription ID, and I will give you more details about it as well. So let's move on to asynchronous communication. This is piece of a engine code that is responsible for exposing the information, whether actually the response arrived from VDSM or not. So over here, we are using Resource Manager, and there is a new method which is called run async VDS command, and that method will return VDS async return value. And on that value, you have a method to check whether the request was completed or not. And based on that information, you may decide to do something else or process your response. So till now, we always were waiting for the information and for the response. And right now, we can just check whether the response is there. If not, we can do something else. So this is nice infrastructure, and this is actually exposing how Jsonrpc works, the implementation from 3.5 release. So by having this method, we are exposing the information that the communication actually happens in a synchronous way. And if you want to actually look at if you are looking for any specific examples actually that work, please take a look at the page that you see the link over here, and over there you will find fully working examples of how to use async invocation of commands. Over here, we can see the event format. So as you know, in 3.5, we have decided to go with Jsonrpc 2.0 specification. And as a part of that specification, there is a notion of notification. This is the name of it in Jsonrpc 2.0 spec. And this is how it looks. And we have adopted it a bit for our needs. So as a part of the method, we are actually sending the subscription ID, and I will cover that later during the presentation. And as a part of parameters, we send the content, the information that we wanted to send from VDSM to the engine, and everything else is according to the spec. And as I said before, we have decided to have mini broker implementation inside of VDSM, and we have 3 modes how mini broker currently works. So we have legacy mode for 3.5, and we introduced that mode because of naming that we use in 3.5. So if there is a specific name, if you subscribe to specific destination, then and that destination is the old name that we used to use in 3.5, then you will actually run the legacy mode. For standard mode, we actually started to use naming convention from ActiveMQ, and that's why we have the difference between legacy mode and standard mode, because the naming. Okay, we have a question. When you issue an async command, do you need to reissue it after each event is received? So async command has nothing to do with events. Async commands is actually, when you think about RPC as we have right now, we call VDSM, for example. The easiest way would be to use get the VDS caps, the VDS capabilities. Then once we trigger the invocation, we don't wait for a response. We just return to the calling code, and then we have an object like a feature. And when we call whether the response actually arrived from the other end, we can actually check that. Before in 3.5 we had no functionality, so asynchronous call of the commands has nothing to do with events. I will cover how events work and what are the differences later on during the presentation. And the third mode of the broker is, if you like, you can use VDSM as a broker. So if you subscribe to destination which is not known by VDSM, and I'm saying known, which is the legacy mode naming or standard mode naming, then you can use VDSM as a stone broker. The functionality is a bit limited. It's not fully, the spec is not fully implemented, but you can use it. Okay, so the small update from asynchronous commands invocation perspective is that you can actually use the asynchronous behavior from command coordination logic inside of the engine. Let's move on to reactive stream implementation. So we have decided to go with reactive stream implementation, and this is quite interesting idea. I mean, set of ideas. And to give you background, there is a JSR 166 which actually proposes that functionality as a part of JDK 9, and it was proposed by Doug Lee. And the reactive stream specification as it is, it is a bunch of interfaces that were created by people having saying actually a lot of networking issues, and they have decided to provide a solution for handling streams of data with not blocking a feedback loop. So from the consumer perspective, you can define exactly how many messages you can consume, and this provides actually really nice mechanism, because on one side, if you are fast as a consumer, you can receive information from producer as a push request. So the information actually will be pushed to you. Whereas if you're a slow consumer and then you use the feedback loop for providing information how fast you are, it will become a pull mechanism. So the interfaces as they are and how the issues that they solve, they can really nicely and inflexible way give you a notion of balancing between push and pull, which is really nice. So we have decided to use those interfaces and provide our own implementation, so we can subscribe to events and define how much events we are able to process by calling request and the number of messages that we want to receive on a subscription object. So this is a class diagram of the implementation that we have on the engine side. And if you take a look at this class diagram, the response worker class, in which we can see in the lower left-hand side of the picture, the response worker actually is part of the implementation for Jsonrpc as it was in 3.5. Subscription ID. This is actually the most important concept from event infrastructure perspective. We noticed that we need a notion of understanding which part of VDSM code triggers the event, and on the engine side, understand where to deliver the event. So we have decided to use an ID which is divided in 4 sections. The first section, the receiver section, it gives us information from which host the event arrived. The next section is the component, and the component is you can think of it like virt, storage, a network. So this is the logical component that you can think of it as a namespacing of operations and unique IDs. And the operation ID, the next part of subscription ID, is actually the operation that is being performed in the time when the event triggered, the event was triggered, or the information what the data means for us. So this can, at this stage, we have decided to map it one-to-one with API that we already have. For example, if you want to have information about image.move, then you use that image.move over here, and then the engine will able to understand that this actually part of this piece of information contains the data which is responsible, which actually is valid for image.move operation. And unique ID actually identifies in a unique way the object on which the operation is taking place, like VM ID, storage domain ID, image ID, whatever it is there. Whatever we are doing with it, we can use it for event delivery. And nice thing about this is that both parties, VDSM and the engine, know the information, know all of the data. Engine knows exactly the operation, the unique ID, and VDSM knows it because VDSM is performing that operation. So having those, we can uniquely identify places from where we trigger the event and to where we want to deliver it. And this is the flow. Actually, this is the response to the question about the async invocation. So the top of this sequence diagram is we are triggering a command. So we are calling a verb if we are using VDSM wording. So we run command and ask transport interface for it. We send it over using reactor. The reactor on the other side is collecting that information and passing it to Jsonrpc binding, because at this stage we are using Jsonrpc, and Jsonrpc via bridge.py is calling the API. And please take a look that if we run the command, we haven't waited for the reply on the engine side. We just returned the call, and the information about response actually is delivered later, and we update the user when the response arrives. And from to set a difference between how Jsonrpc worked and how the events work, actually, if you look at the lowest interaction, so at this diagram we have a long-running task. I just created it like this. It can be anything that it takes a lot of time. So from that task, you can trigger an event. So the task actually calls the reactor. It's just simplification of the logic in VDSM. And the VDSM reactor sends it over the wire. And on our subscription, we call method on next. And then the subscriber gets actually the information. It's maybe it's not clear how the messages are delivered, but when we see the sample code, how to use it on the engine side and VDSM side, it may become a bit clearer. So we have the asynchronous communication as it is in Jsonrpc, and then we can use events. And events can be used as a reply for running a command, or can be generated during the lifetime of VDSM, like VM monitoring. You can trigger an event on any time, and it will be delivered to proper part of the engine. So moving on to how to receive an event on Resource Manager class, we have a method which is called subscribe. And for that method actually accepts the event subscriber. The event subscriber is an abstract class, and you need to provide an implementation of it. And as a constructor parameter, we accept actually the subscription ID. So at this stage, you can see that we actually expecting the event to arrive from particular host defined by get_vds hostname. Then we don't care about the component. We have decided to use VM status for VM monitoring operation ID, and we don't care about the VM, so there is asterisk over there. So any VM from that particular host, which actually is performing the status update, then we will receive that information. And we have bunch of methods to implement from event subscriber. There is on subscription. So this method is called when we subscribe, and we can open resources like files or anything, or just anything we want to be before the initiation. And over here, as you can see, we actually request single message over there. So we are expecting single message, and there will be no deliveries unless we ask for more. So this is the power of reactive streams, and it do not logs. Next, the most important method is on next, and over here whenever the event arrives, this method will be called, and we can process the data that is inside of the event. And please take a note that once we process it, we request the another message. So before we won't finish the processing, no more messages will be delivered to that code. Of course, we can ask for more. We can ask for 100. We can ask for 1,000 messages, and then they will be delivered as they arrive from VDSM. Next method on error. This is the method. This method is called whenever something happens with communication. So if the if the connection is broken or anything happens internally in the implementation, we will be notified about that by this method. And on complete, this method is called whenever we call subscription.cancel, which means that we no longer want to receive any events. So this method is for closing anything you opened in unsubscribe. And this is how it looks from the engine perspective. Are there any questions about the implementation? Okay, so maybe let's take those questions if you have any at the end of the session. And triggering an event from VDSM perspective. So this is piece of code which is simplified piece of code from VM monitoring. So we gather a bunch of stats about the VM, including status, and we call notify method. And please take a look that we built the subscription ID, the ID that we talked about it. And then we actually call client IF notify method with the subscription ID and the information, which is the stats data that we want to send. And this is everything that we need to do from VDSM perspective to trigger an event. And that event containing the stats dictionary and particular subscription ID will be delivered to the engine. Please note over here that from VDSM perspective, we are not providing the receiver part of subscription ID. And the reason for this is that we don't really know the IP address or the naming, how the engine recognizes particular host. There can be multiple network interfaces, or the engine can understand, can know the IP address or the host name. So we don't know how the engine calls us in the database. So what we do on the engine side, actually, whenever we receive an event, we know exactly from where the event arrived. So we actually add that. If not there, we add that information, the receiver information, to the subscription ID. And based on that, we can actually match properly the message to a subscriber or multiple subscribers if there are more than one subscriber subscribed to a particular event type. So there are limitations of the implementation of the subscription ID. So first of all, if there are no subscribers for a particular event, the event won't be delivered, and it will be, once the event arrived to the engine side, we try to match the event based on subscription ID to subscribers. If there are no subscribers, the event will be dropped. So nothing will happen. On the other side, on VDSM won't send any events if there is no one who actually subscribed to jms.q.events. If there is no connection which actually subscribes to that particular naming, and this is the destination from the Stomp perspective. So this is Q name. If no one is subscribed to that, we won't send anything from VDSM. And as a last, we have no guarantees that the event will be delivered. So there can be network interaction. Once we call client.if.notify, the event is still stored in memory. If VDSM crashes, then there is no delivery. If the engine crashes on the other side, on the other hand, there is no delivery. So we have this loose guarantee that event may be eventually delivered. I mean, the event may be delivered, but there's no like 100% that it will be on the other side, because of the way how we defined the engine, how we define the PDSM, and how the networking works. I would like to cover the implementations of this nice framework. So as a first implementation, we have decided to go with VM monitoring. I will give you more details about the implementation in a sec. We already saw the examples taken from the engine code and VDSM code, which are used for VM monitoring. So those are the implementation of event subscriber class and calling client IF.notify are the interfaces to interact with eventing infrastructure. As well, we have explored the DHCP IP assignment. There is a bug which actually says that the IP address is not updated before it is assigned, because we don't know about the address. So there was an idea actually to trigger an event when the IP address actually is assigned to a host, but that logic is part of Super VDSM, and so far we haven't decided to provide a infrastructure to send events from Super VDSM. So because of that limitation, we haven't decided to have it in for 3.6. So let's talk about VM monitoring a bit more. So this is the data that we send. If you think about how much data we send over the wire for monitoring cycle in 3.5 or below, we actually have decided to reduce the amount of data significantly for the events. And one of the important things over here is that each and every event will contain notified time. So if there is a need for you actually to understand when the event is sent and whether there is proper ordering of the events being delivered on the other side, maybe due to networking or due to threading model as it is in Java, the events may be in wrong order. So we provide you a notify time as a part of each event. So then if it's important to keep the ordering of the events arriving on the other side, you can use it to actually decide whether the event is newer or older. And as a part of VM monitoring, we provide new status of a VM. So if the VM actually was up and then moved to down, we actually send you that information. As well as a part of that event, we send a hash of the devices. We need that for VM monitoring code to understand whether any devices has changed. And if the status is done, we have additional information that we provide as a part of the event. And this is a great example how to understand what are the differences. And assuming that we have 200 hypervisors, and those numbers are the number of messages per minute that we send over the wire. So by default, get all VM stats is triggered every 15 seconds, and get VM list is triggered every 3 seconds. So multiplying that by number of hypervisors, you have like 4,000 messages per minute that we have. And if there is any status change, we actually have additional call for all of those VMs that the status has changed to collect information about exactly the status, what is the difference, and other information. And in 3.6, when we use the eventing infrastructure, we still use get all VM stats. So there is no difference. We have still 800 messages per minute. when we use this number of hypervisors, but we don't have the get VM list at all. And the events arrive, which is the incoming information only, with the amount of data that you saw on the previous slide. So you can see the difference, how much data we sent over the wire when using events and when we do not use events. And it is very important that get VM list is triggered every 3 seconds, and event is triggered every time that something changes. So from that perspective, the user knows faster about any information that occurred on the other end. And by that, we improved user experience because they have less stale data on the UI. Future plans for eventing infrastructure for the communication layer in Ovirt overall. So as I said, that there is, as a part of reactive streams, there is a notion of a feedback loop that you can provide information to the producer. In our case, it's VDSM, about how much messages you can process. And right now, the feedback loop ends at the engine. There is the feedback loop do not send any information to VDSM. And why it's needed? For example, imagine that if you have big number of VMs on a single host, the monitoring lifecycle logic can take a lot of time. And because of that, we may actually get a lot of information from VDSM side, but we are still processing the older information. And by having that mechanism, actually we can get the amount of information that we are capable of processing without any additional information. The next feature that we thought about could be useful is the aggregation. For example, if you think about Monday morning effect, if there's a lot of information changing in a short period of time when people actually arrive to the office early in the morning on Monday, then we may want to actually aggregate, and by aggregation we can throttle the amount of information that is sent over the wire from VDSM to the engine. And this actually could solve the issues like Monday morning effect. What we want to do is we want to think about using actually a real schema real schema. And what I mean by that, we would like to actually define the interface between the engine and VDSM. Right now, the interface is a bit flexible, and we grow the API instead of actually changing the API. So we need a common schema between the engine and VDSM, so we can actually nicely define the interface. Maybe by using versioning or other means. It wasn't decided yet, but it seems like it will ease our maintenance later on in the future if we decide to actually go with that idea. And what we would love to see is actually widespread use of the eventing infrastructure for other parts, not only VM monitoring, but storage, for any storage-related task which take a lot of time. And for example, you would like to update user about the progress, the events are a perfect solution for that. You can trigger, if, for example, if you see 10%, send event containing 10% information, and then the user will be aware that the operation is 10% done. Or from VIRT perspective or from network perspective, there's a lot of use cases that we can actually start using events for. As a future thing, I would like to move from mini broker as it is in VDSM to real broker, but this means that we need to solve issues like host lifecycle, because we depend on peer-to-peer connection between engine and VDSM, and based on the state of the connection, we can decide whether actually VDSM is up on or not. When we start to use broker, the middleman between engine and VDSM, then it is not so trivial. So we need to solve those kind of issues. So we may decide to actually move away from mini broker to the real broker later, and then decide whether we want what kind of topology we want to use for the broker. So to sum up what we actually talked about, we talked about the eventing infrastructure, how it looks like, what are the changes between Jsonrpc as it was in 3.5 and the eventing infrastructure built thanks to Jsonrpc code that we released as a part of 3.5. So we covered the examples, how to send and how to receive the events, and we talked about the pieces of the code that actually started to use the infrastructure and the future plans for it. So thank you very much, and if you have any questions, just feel free to ask. So what is the benefit of it in a real broker? If we decide to actually use real broker, we may, it is actually transparent for us how we process the messages and how the messages are delivered. So by having that, we can actually, for example, from VDSM perspective, one day we may decide to actually divide VDSM into subcomponents like networking, virt, storage. Everything will be separated processes. So we can use that broker as a means of communication for those processes in a similar way like OpenStack works. Those are just open ideas that we throw around. We don't know whether actually we go with that direction. The other example is, for example, if we wanted to actually cluster the engine, then having real broker that will actually deliver messages to all of the nodes in engine cluster can be done as well. But this is just really far away from us if we want to have something like that. So there is a benefit of it, but not in short period of time. As well, it has disadvantages. Like I said, we need to change the host lifecycle logic because we really are dependent on peer-to-peer connections. So it is not like it has only gains for us, but we need to actually adapt to it. So right now, because of that, we haven't decided to go with it because we are not clear what will be the advantages and what is the price actually to introduce it. Are there any more questions? Okay, if not, then thank you very much. You can always send me an email if you actually think that you want to ask something or you want to influence the future of this code. Then send me an email or chat with me on IRC, and then we can take it from there. All right. So thank you very much for your time. Thank you. Bye.